Okay, so the final lesson in the chapter on integration is about what we call the trapezium rule. So basically, we're taking the areas under the curve and breaking it into intervals where we'll add the areas of all of the trapezoids that it's made up of. So here I have the equation y equals x minus 2 ln x. They're going to tell you how many intervals you need to break it up into. So here it starts at 0.5 and it ends at 3.5. And they want us to divide it into two intervals. Well, this just means we find the point that's halfway between 0.5 and 3.5. So you can go ahead and average those. Added together, it's 4. Divided by 2 is 2. So here's my other interval. So this is what we would do if we didn't know how to integrate, just to make a guesstimate. Now, the last part of these questions is going to say, is it an overestimate or underestimate of the actual area? Now, this is always asked last, but I do it first because you don't actually have to do any math to figure out that part of the question. So, where these points are hitting the curve, or these lines are hitting the curve, create points. You're going to connect them with line segments. So this is the area under the curve. If I found the area of this trapezoid and this trapezoid and added them together, would that be greater than the green area or less than the green area? Well, there's a bunch of extra space in this trapezoid that's not under the curve. So because the line segments are over the curve, this is an overestimate. Because those line segments are above the curve. So the next step, we have to make our XY table. And we have to include each x value that makes up these intervals. So here I will use 0.5, 2, and 3.5. Okay, and you go to 4 decimal places for y. And all you do now is take these x values and plug them into your original equation. So here I would do y equals 0.5 minus 2 ln 0.5. When I plug that into my calculator, I get 1.8863. So you'll just do the same thing for all of your x values. If I plug in 2, I get 0.6137. And if I plug in 3.5 to 4 decimal places, 0.9945. We also need to find h. Now, normally we think of h as going up and down, but h is actually the height of the trapezoid. So h is the distance or the length of each interval. In order to get from 0.5 to 2, I have to travel 1.5 units, so that will be my h. Okay, there's a formula, and it's on your formula sheet, but it looks a little crazy, so I'm just going to explain to you what you need to do. And then if you want to check out the formula on the formula sheet and see how it works, you can do that. So to find the approximate area, we have h divided by 2. Then you multiply that by the first y plus the last y plus 2 times the sum of the y's in between them. So my first y is 1.8863. My last y is 0.9945. Then I have to multiply everything in between by 2 after adding it together. But here we only have one y in the middle, so that's what I'll be multiplying by 2. Let's go ahead and plug what we have into our formula. 1.5 divided by 2 times 1.8863 plus 0.9945 plus 2 times 0.6137. So just watch your order of operations and etc. as you're plugging it into the calculator. And then generally they're going to want you to give the area to 2 decimal places. We just took it to 4 here, so our answer will be more accurate, especially it's an estimation already. I like to be as accurate as possible. So I plugged all of this into the calculator and to 2 decimal places. The area should be approximately 3.08 square units. However, remember, this is going to be an overestimate. So the actual area under the curve will be less than 3.08. If you want to actually see what the area under the curve is, you can use differentiation and compare how the estimated answer is related to the original or actual area under the curve. Here we'll see the graph of y equals 2 times the square root of 4x minus x squared. They want you to use 4 intervals to estimate the area. Is it an overestimate or an underestimate? And find the approximate area. So first we're going to divide into 4 intervals. So if it's 0 to 4, that means I'm going to have an interval every 1 unit. So let's connect our points with line segments. So if I took the area of these triangles and trapezoids and added them together, would that be more than the area under the curve or less than the area under the curve? Well, because these line segments are under the curve, if I find the areas, I'm going to be missing these spaces here, so it's going to be an underestimate. What is h? Remember, h is the space in between each interval. So h here equals 1. Now we do our table. Zero, 1, 2, 3, 4. So I don't need to plug in 0 or 4 because those points are on the x-axis. So my first y and my last y are both going to be 0. we need to plug in the rest of the values for y equals 2 times the square root of 4x minus x squared. Here, I would get 2 radical 3. Here, it's 2 times 2, which is 4. And here we have 2 root 3 again. Okay, so the formula is h over 2 times first y plus last y plus 2 times the y's in between, the sum of the y's in between. So here my first y and my last y are both 0. These are the ones in between, so we're going to add them together in these parentheses. And remember, h was equal to 1. So 1 over 2 times 0 plus 0 plus 2 times 2 root 3 plus 4 plus 2 root 3. So remember to add them together and then multiply by 2. And when you plug all of this into your calculator, you should get approximately 10.93 to 2 decimal places. And the actual area under the curve is going to be a little bit more than that, since this was an underestimate.